user group. We are actually changing things up, so I've been leading it for a while, and I keep on asking, who else wants to lead it? We want to make this customer-led. So we've had a couple customers that have volunteered to lead it. So it's now going to be Josh Farmer and Luke Teeters are going to be taking over and handling the reins from here on out. So I am actually going to officially hand the microphone, since we have a microphone, over.
All right, well, this is the first session that Luke and I will be conducting, so we don't quite know how it's going to go yet. We haven't quite figured it out, but I figure we'll just take feedback from everyone and just kind of learn from the experience, and I'm sure it'll get better from here, but just bear with us as we figure things out here. But
thanks for coming.
yes, yes, definitely. So we have the agenda. Obviously, we're going to go over icebreakers, introductions, the move to the public cloud, experience with the security and production environments with legacy antivirus. Luke's going to be talking about that and actually giving his speech that he's going to give at Ignite. Then covering PAN-OS 8 updates and just various customer discussions and everything else. So, yeah. All right, so I guess we'll start around the room. Pass the microphone around, or
No.
okay,
I guess we could start. So I'm Luke. I work with Josh and Materion. We're big Palo Alto customers. We run traps on the endpoint. We're going to present that today, and we're happy to be here. So I guess we could start with Ron here.
I'm Ron Texer with Lincoln Electric. I've been using Palo Alto firewalls for about 4 years, but haven't done a public cloud deployment yet. Probably will be soon.
Jonathan Ross. I work with Ron at Lincoln. I've been dealing with the Palo Altos probably for about 6 to 8 months, so I'm still getting my feet wet, still kind of learning the system.
Mr. Davis, Metro Health. We've had our Palo Altos in for, what, about 8 months now? About 8 months. We're just starting cut to 365 and interested in traps.
Tim Ross, Metro Health System. Basically, as Stuart said, we're going to Office 365.
Dave Masnick, Cuyahoga Community College. We have various public clouds, like Office 365 or whatever, but we don't have like the platform, so to speak.
Tony Mancini, Cuyahoga Community College, Office 365.
Cool. I guess we can go here, maybe.
Doug Robinson, Joanne Stores. I'll let those people tell you what we use it for.
Did the whole table?
Wow. Big Rezak, Joanne Stores. Greg Detweiler, Joanne Stores. We've been using Palo Alto firewalls for a little under a year now. And use traps as well, but some of the guys can talk more about that. As far as public cloud, we are Google Apps or G Suite now shop, but nothing really as platform as a service, but certainly looking for that in the future, hopefully.
Jason Nestor, Joanne Stores. I don't know what more to say about the fact that we use traps, but we do in fact use traps. Is that what you want me to go?
Yeah.
Okay, cool.
I have a question for you guys. Is this your whole team? So what happens if...
No, so the last one, just like 2 weeks after the last one, said, hey, there's free food. And
there you go.
Yeah, that happens.
Bob Messer, Joanne Stores. Pretty much what Jason said.
Eric Young, and I'm not with Joint Stores. Vitamix Corporation, we've been using the Palo Altos for just over 3 years. Not using traps or any of the other products, and have not done any cloud deployments.
Greg Kazmarek, Crystal Clinic Orthopedic Center. We've had Palo Altos in for a couple of years now, and I'll let him discuss what we use it for.
Michael Materna, Crystal Clinic. Been working with Palo Alto for about a year now. And biggest project right now is a new WAN provider and possibly a PAN 220 at a remote site.
Marcus Manis from KeyBank. We just started our path to Palo Alto firewalls. We're moving from Juniper Nursery and ASA firewalls. So about 3 months experience.
I'm Shara. I am a business development consultant. started in the cybersecurity industry right now, so looking forward.
Hi everyone, I'm Elaine Anderson. I'm one of the system engineers at SimaHealth. I work under Rich Michael. He's one of the architects, so I'll let him explain the projects for you.
I'm Rich Michael with SimaHealth System. We've used Palo Altos for a few years. Greg used to work there with us. We are going to, we have some 50/50s. We're going to be moving to some 52/20s. We don't have anything in the public cloud at this point, although we're doing a beta with Office 365.
You guys want to go here?
Ed Doherty, Compression Insurance. We are just in our infancy in Palo Alto. Actually, we're doing our first production migration to our VPN from Network Security Manager this weekend.
Nice. Cool. Good luck.
Dave Frenick, Fairmont Central. We've been running Palo Alto for a little over a year. We went from ASA environment. We're starting to roll out some 8220s with Palo. And we're starting to look at some cloud integration.
I'm Mickey Antarenko from Youngstown State University. We've had Palo Alto firewalls in for about 4 years. I'm new to the department, information security engineer, and some more information.
Paul Adams, Sherwin-Williams. We're actually just starting to spin up kind of a bake-off project with Palo and Cisco. Others.
Maverick House, also from Sherwin.
John Miller from CBiz. We've been with Palo Alto for about 4 years, and we have not done a public cloud implementation yet.
Darren Novak, Cleveland, and we've been using Palo Alto for about 4 years.
I'm doing Border from Chittagong Medicine. We've been using Palo Alto for 4 years. Never been using public cloud for hospitals, so not really making a change right now, but I am in the transfer.
Tim Devendra from Tim Steel. We've been using Palo Alto for about a year and a half now. We've also used Traps for legacy system protection. Started looking for 55, but other than that, nothing cloud-based work data. I'm Brian Patterson from Tim Steel. Same thing as that.
Scott Simchek from Logistics Steel. We don't have public cloud deployment, and I don't see us going with Logistics Steel.
Paul Kemper from Kai Corporation. Been installing Palos for a while now. As far as public cloud, I helped a few customers move to public cloud this last year. So it's a 365 content.
Cool, I think that does it.
Yeah, that's everyone. So
What about you guys?
Yeah, I'll go. I'm Tyler Snetzler. I'm the named account manager. I'm the account manager for the majority of the folks in the room, I believe, a little over half at least. Thanks for coming.
My name is Mike Smuck. I work for Microsoft. I'm a technology strategist. You're probably asking yourself, why is Microsoft here? Well, Ben and I worked together in a previous life, and he asked if I had anybody who could come talk about public cloud and public cloud networking security, and that's why we have Oliver.
I'm Olivier, in fact. Some people say Oliver. It's okay. There's one more I. We come from Montreal, French Canadian, and I work in the Azure team at Microsoft networking.
Great. You guys in the back?
Walter Abel, also Palo Alto Networks. I'm the traffic security engineer, so 3/4 of you already know.
yeah, actually, long time no see.
All right, so I guess we can kick it off and start talking about it.
Actually, we're gonna have you speak because I know you have to go a flight. So
yeah, you want me to speak before you guys?
Yeah.
Okay.
We want to make sure you have enough time to go over everything you wanted to go over.
Yeah.
Almost kind of like you don't need a microphone. More than welcome to it.
All right, can you all hear me? No. Do I need a mic? No? All right. So that thing should be on. And I'm gonna move it. Okay, so here's, yeah, I heard some of you say you're not in the cloud yet. Some might want to be, or look into these ventures eventually. I'm hoping today that I'll be able to convince you that cloud is not that scary in a way, right? From the networking security standpoint, there's obviously other concerns that you might have as customers and users of the cloud, but I'll try to do my piece on the networking side and security side. So kind of the topics that I want to go through, just real quick, Azure networking basics and cross-premises connectivity, cloud networking and virtual appliances, and kind of the scenarios that we can do with these things. So first things first, you know, when you have you create virtual networks, Azure is a platform that allows you to create many things. One of the things, kind of the basic foundational tools of network, is virtual networks in Azure. So you create your own networks, you use your IP address space, you can treat this as an extension of your data center. We have a lot of customers doing that, right? And you need also connectivity, because this normally does not live in an isolated island. So there's people accessing this from the internet because you might be exposing applications or workloads to your internet users, to your own users, or you might have back-end connectivity, or both. Right? You could have a VPN that connects there, you could have ExpressRoute. I'm going to talk to you about these things and how you secure them, at least in a way. So for those of you, are some of you guys familiar with enterprise networking concepts like VRFs and VLANs and switches and routers? Yeah? Okay. So a VNet, or a virtual network, I often refer to that as it's not a VRF, but I think of it this way. It's not a VRF because it's not exactly a network. Like you would see it on premises, there's things that don't work. For example, layer 2 things don't work. Most things. ARP works, but a lot of other things don't work. So you can't rely on those things, those functionalities being available to you. And you can divide them in subnets. You can think of them as VLAN, but again, they're not really broadcast domains. Because broadcasts don't work in public clouds. But you can divide that just like you would divide VLANs with their different IP addresses on different subnets. And when you want them to talk to each other, it just works by default. Think of this as this is a big layer 3 switch. Everybody is able to talk to everybody and directly. There's no such thing as a gateway. If you look at the IP configuration of one of your machines, you will see it has a default gateway. And the reason is simple. If you don't give a default gateway to a VM, it doesn't work. Well, it works, but it's pretty alone there. It doesn't work with the rest of the guys. So that's why there is this, but it's emulated. Azure emulates it to the virtual machines, so they can all talk to each other. So that's a real quick primer on what it is and kind of the components. Now, one other piece is, I'm not the security specialist all up in Azure. There's tons of certifications and compliance and these things. It's not exactly where I'm super knowledgeable, but on the networking side, this is kind of our story, where we have, for all the endpoints that you have in Azure, but by public points I mean endpoints that are exposed. When you create a virtual machine, you can have a public IP. You would have a firewall, for example. You could have a Palo Alto firewall. It has to have a public IP. Maybe not if once you've configured all the other ways to access your virtual network, not. But if you do create one right now, you don't have any other means to access it other than the public IP. That public IP would protect it with our DDoS infrastructure. It's a massive DDoS infrastructure that we have at Microsoft. And all these endpoints are protected. And after that, if another customer has another virtual network beside yours, they're completely isolated. There's no way that they can go from their virtual network to your virtual network without you allowing them to do so in one way or another. And then within the virtual network, you have NSGs, which are network security groups, which I'll talk to you about a little bit later, and UDRs, which are user-defined routes, which are very useful for scenarios where you have firewalls or other traffic inspection, traffic steering devices. And after that, you have your virtual appliances, if you have Palo Alto firewalls or other appliances, and your deployments that are in the middle of this thing. So there's multiple layers of security when it comes to virtual networking. Now the other piece is as I said, the NSGs, stands for Network Security Group. It's an ACL. So an ACL, an access control list, it's a 5-tuple in Azure. So it's the source IP, destination IP, source and destination port. It's not a firewall. This is why there's guys like Palo Alto, because they provide more security, and certainly it's not unsecure, but it filters at the port level. If somebody is screwing around and trying to do a SQL injection on a web server, that NSG is not going to see that. It works at the network layer. It's extremely fast, doesn't slow down the traffic, but it's not a layer 7 firewall. It's really just an ACL controlling the ports and the protocols. That's what it does. Not going to go into a lot of details about that, but it's stateful in that you don't have to open it in both directions. Right? If you open port 22 inbound, the return traffic will just work. The platform makes it happen. Okay? And interrupt me if you have questions. I mean, if they're longer, I'll take it offline at the end. So that's kind of the model where you can have NSGs that are applied on the inbound flows, at the subnet level, and at the NIC level, and on the outbound flows in the other direction. They're cumulative. This is kind of the built-in things that you have for securing the network at the network layer in Azure. So far, so good? Okay. Now, when you want to do cross-connectivity, when you want to connect your premises, your data centers, or your network, or you want to allow access to your virtual networks from the external world, these are the 4 possibilities that you have. I talked about the internet first, obviously. I mean, it's either for limited deployments. You could have somebody opening up RDP on a VM or SSH and allow access in the VNet, and from there you can do your things. That's typically does not scale a lot, but it could be a web service that's offered from there. And if that web service, for example, would need back-end connectivity, it could be the web service could be in Azure, but the data tier could be on your premises. How does that work? VPN or ExpressRoute? VPN built into Azure, you could always use VPN of Palo, as long as the routing is configured appropriately, that would work. But there's Azure VPN gateways. There's point-to-site and site-to-site. Point-to-site is like a client you install on your workstation. Pretty common scenario for users of companies working from home. You dial in VPN in the office. That's what it is. Site-to-site VPN, it is what it is. And ExpressRoute is a higher speed connectivity with an SLA. So essentially, when you create a virtual network gateway, a VPN gateway, it's that thing that you have here that lives on a different subnet. But it's part of your virtual network, the same virtual network we talked about earlier. And those virtual network gateways, they're virtual machines. They're not that different, but they're highly available. You don't have to worry about high availability, which sometimes is a concern, depending on the kinds of workloads. And when you create those gateways, you get a public IP, you terminate your VPN there from whatever devices you have on the other end, as long as it's compatible. Typically IPsec devices are, right? And notice here there's one virtual gateway, and then there seems to be 2. Well, one is for VPN and the other one is for ExpressRoute. Because you could potentially have an ExpressRoute connection to a virtual network and a VPN as a backup. That's one way that customers sometimes do. Sometimes they have 2 ExpressRoute connections and back one ExpressRoute connection with the other. VPN is also a frequent scenario. And then, that's just how it works. You've got a public IP, as I said, terminating on-prem, and it works like any other VPN does. Yes?
So, do you need a VPN gateway per VNet, or are you able to share a VPN gateway through multiple VNets?
That's a great question. You can do both. And I'll show topologies later on how you do both. So that's a very quick primer on VPNs. Now ExpressRoute is very, very similar conceptually. From a routing standpoint in Azure, in fact, it's the same. Pretty much the same thing. But there's a difference, is that there's an IP tunnel here that runs on our backbone up to a provider. And you, as a customer, have to connect to that provider. The meeting does not happen in a Microsoft data center. The meeting point happens in meeting points, express route locations. So the express route locations, symbolically, that's what's in the middle here. So you got the bottom right cloud is your VNets typically. This refers to the private peering. There's 3 BGP sessions running here for potentially 3 peerings. One for the private cloud, where you could connect to multiple VNets there. One for the public peering that connects to platform services. So like SQL Azure, for example, or storage, or web apps, or there's a lot of services that have public IP addresses. That's essentially the difference. You know, the VNets, what you create inside of your VNet is your business. Typically, we see customers putting RFC 1918 addresses. You can't put public IPs if you want. We are not routing them. But if you want to route them yourself, you're good. The public peering is really public IPs. So what gets advertised to you as a customer is a lot of IPs. The IP addresses of our Azure data centers, which is a lot of them. And the final peering, the other peering, is the Microsoft peering. And as the icon suggests, that's the peering for Office 365, essentially, with public IP addresses. So again, there's 3 peerings that work for ExpressRoute. And ExpressRoute, quickly, you see on the right, there's the Microsoft network, which is our huge backbone, and the Azure and Office data centers. And you've got your customer network, or your organizational network on the left. So ExpressRoute is really, that meets somewhere at the middle, at an ExpressRoute provider. And the middle is represented by all these dots on the map. It's edges to our network. And all partners that we're doing business with, and even if your carrier is not one of them, you could always get to one of the locations in an Equinix, for example, or core site through any carrier you want. And from these core sites or Equinix or Cologix or other hosting partners of ours, you can hop onto our network and get to your virtual network. I guess that's pretty much the point. So the 2 models on the left is what I just said. So you're getting a layer 2 connection at a cloud co-location, or you're extending that cloud co-location to your facility using any carrier, or I know that level 3, for example, does this service, or you would use an AT&T or Verizon or other MPLS provider, such that Azure becomes one leg of your network, of your MPLS cloud. And from there, you can extend the connection to your virtual network and create that private peering that's on the bottom right. This is a typical scenario that we see customers using and deploying, and how, I mean, it can be significantly larger than that, your environment. But we see a lot of customers like kind of having this ExpressRoute connection and then their provider network, and terminating this maybe inside of their network. Maybe not, maybe on a different security zone from your firewall standpoint. You could have a firewall here or choose not to. Or a lot of customers start having firewalls here in their virtual network. And that's what I'm going to be talking a little bit further. But that's for the private peering. The public peering, we typically see customers terminating them at an extranet firewall, some perimeter firewall. Because it's public IP addresses that we advertise to you, and you also need to talk to us with public IP addresses. There's got to be some NAT happening somewhere. Same goes for the Office or Microsoft peering. Pretty much the same idea. Any question? So far, so good? Okay. So that was how to connect to the cloud. Now, how do you connect within the cloud? This is another, once you could choose that you have more than one virtual network. And why would you decide that? Well, for one thing, maybe your virtual networks have to be located in different regions. One virtual network lives in one Azure region. We have like 36, I think, regions across the globe. So you could have workloads that live in US East, in North US Central, in US West, wherever. And for that reason, if you need those workloads to be geographically located elsewhere, you might need those VNets to talk to each other. Quite easily, you could create that VPN between the 2. But that could scale, right? You could have 3, and to achieve any-to-any connectivity, you could have this full mesh thing, or use BGP instead. It's kind of a one configuration option. When you use that, well, everybody learns about everybody, and everybody is able to talk to everybody, but everybody goes through that. So you keep this in mind in terms of performance. If you have a 50-to-1, maybe this guy will struggle a bit. It's important to keep this in mind, or use Palo Alto appliances to do that, or a combination, because they can VPN from one to the other. Another option when you have an express route circuit is something like that, where let's say that this is in Chicago. This is your express route circuit in Chicago, and this is in North Central, and maybe this is in US East. Well, when you connect this with that express route gateway there and that express route gateway there, and you create the connection to that same express route circuit, a side effect happens. You've got two IP tunnels connecting to one router. Guess what? They talk to each other over a backbone. So you leverage your backbone to carry your traffic from one region to the other. And that happens at pretty high speed. That gateway is a 1, 2, or 10 gigabits per second. So that's kind of neat. Again, this scales from 2 all the way up to 100 VNets that you can connect to the same express route circuit. Again, it depends on what your needs are. And to get back to your question on can you share a gateway, you can with VNet peering. So what is VNet peering? It's essentially extending kind of a boundary of VNet A to get to VNet B. They work pretty much in the same way. Right? If you think about it, this is all a virtualized network. So for us, it's like we're extending the lookup table to see VM1 wants to talk to VM1 here. Normally you would not find it, but because they're peered together, it knows where to get. And it goes at the same speed as if it were one VNet. Yeah.
Is that using VXLAN or some similar methodologies?
Some similar methodology. Maybe a Microsoft version. But I mean, it's network virtualization.
Another question for Excellent. So the traffic, once you have the peering, it's managed by the system router between the two VNets?
It's what?
Is it managed by the system router? So you have a system router per VNet, right, which manages traffic between the different subnets. How does it manage between
I guess this is maybe an AWS concept, system router thing. It does not. There's no such thing as a.
Right. So when I create
traffic
a VNet,
is exchanged between VMA to VMB. Period. There's no.
So when you create a VNet and I create 3 subnets within that VNet,
yeah,
traffic gets routed between subnets through magic.
Through magic. It's the same magic that happens here.
So that system that manages that magic, is that going to be the same thing that is going to move traffic between VNet 1 and VNet 2?
That's exactly the same. And this is why you could have 1,000 VMs here talking to 1,000 VMs here at 5 gigabits per second each. There's no such thing as a central point. So the traffic is exchanged directly between the at the end of the day, it's the physical hosts that talk to each other directly, right? So it works, as I said, pretty much in the same way. Works within the same region. You can't peer US East with US West. So you have to keep this in mind. Same kind of performance, whether, I mean, I've tested 24 gigabits per second on one VNet. I could do this across VNets. As long as they're in the same region, because otherwise the peering doesn't even work. And there's a few things, I can give you the presentation after. But one thing also to know about peering is that's not transitive. So 1 to 2, 2 to 3, 1 does not talk to 3, unless you put some kind of, maybe a Palo Alto firewall here. Some routing device, because this guy can be taught the routes to reach this through this guy, and vice versa. And once this is happening, once the rules on that virtual appliances are good, I mean the forwarding rules, if there are such things, that just works. And this is where you can also share the gateway, to your question. So when you have that peering relationship, you could just have, I mean, right now there's one, you can peer up to 50, and yet use one gateway. Create a topology like that, for example, a hub and spoke. A lot of our customers are designing these topologies around virtual appliances to avoid having firewalls there and there and there, and maybe domain controllers, and maybe monitoring servers. and have, instead of having these shared services, because that's pretty much what they are all over the place, you just put them in the hub. They'll need to be, I mean, you need to have pretty solid services. You need to have a lot of bandwidth. You need to think that through. But this topology allows you to do just that. Good? Make sense? Now, one of the key things of using virtual appliances in Azure and securing above the NSGs, or network security groups, is using appliances. And there's essentially two tools that are required for appliances. One is using route tables, or user-defined routes. Because Azure, as I think you said something about the magic, magically sends the packet to where they should go. Well, when you want to put an appliance, you need to influence that magic. And you do this with route tables. Because by default, you've got some local VNet routes, which they are there because you created the VNet. And they are there because the VNet has the address space ABCD. So it's got a direct, quote-unquote, route to that ABCD. But it does not have necessarily a route through another device. It just sends it directly to the destination device. Plus you have cross-premises rules, or routes, which comes from BGP advertisements we received over ExpressRoute, or BVPNs. And internet routes, which is kind of the default route. That's what you see by default, not going necessarily to the details here, but let's just keep in mind that this VNet here has two CIDR blocks. So that's what you find here. And you've got some cross-premises routes that come from what we had on-prem over ExpressRoute. So 10/16, 10/100/16, and 192.168. So these routes get populated into that table. And then you've got the internet default route. This is what's there by default. Yeah, there's a question here. How does a VNet learns about these things? Learns either, in the case of the VPN, you could use a BGP-enabled VPN and have a BGP session with our gateway and send us your routing information, which you have on-prem. That's one option. The other option is a static configuration. Whichever way you choose, these routes gets populated into our routing table and influence the traffic. So that's what I'm saying here. And the equivalent of that happens using ExpressRoute. The routing information over ExpressRoute is exchanged via BGP. Well, that feeds into the route table of the set of virtual networks that your ExpressRoute circuit is connected to. Right here, there's only one. There could be 100. They would all learn these routes. Now, what happens if that doesn't work for you? Because by default, if you create a firewall, no traffic's going to go through that firewall. The only traffic that's going to get to that firewall is because you're going to the management console of that firewall. But you're not going to go very far with it. You can configure it, but no traffic's going to hit it. How do you do this? You would do this using a user-defined route, which is a route table that, in the order of priorities, it goes above all the other system-learned routes, or that are there because this is how Azure works. Because by default, if you have your Palo Alto firewall here, and VM1 wants to talk to VM4, just by following the default route, it will just talk to it. Now, how do you influence it? Is by adding a custom route table to that subnet and another one on that subnet. Why on both? Because you need the return traffic to work too. Otherwise, if your application requires one way, I guess it's okay. Usually it doesn't, unless you get some UDP stuff, but that works. So how does it work if you have a VPN, for example, into Azure? You could use the Azure VPN gateway or ExpressRoute. It's exactly the same idea. And you can have your Palo Alto firewall here in the middle. And if you have a custom route table here that sends the traffic through that firewall that's destined to on-prem, well, where's the return traffic going to go? By default, that's what it's going to do, because there was no routing table here. So when you create the route table and associate it to the right subnet where the gateway resides, this is what sends the traffic in the virtual appliances and stop your sessions from breaking. Otherwise, they're broken all the time. Make sense? So in terms of virtual appliances, I mean, you guys, Palo Alto guys, are better than I am to sell you their platform. but there's all these functions that those virtual appliances can do in Azure. And you will need those UDRs to forward your traffic to these devices, whatever these capabilities are that you do. I'm not sure if you guys are into SD-WAN, but probably do pretty much all the other stuff. So user-defined routes are absolutely key to making that work. And IP forwarding, that's just a property that's probably enabled by default in the Palo Alto templates anyways if you deploy them in Azure, but that's kind of the key things that are required for this to work. The other thing is, Azure is not a well, at the end of the day, it is a physical network, but for you guys, it's a virtualized network. And virtualized networks do not work like physical networks. And one of the difference is, from our standpoint, you could have one firewall sitting here with one NIC. I know Palo probably doesn't have one NIC thing because it needs a management interface, and maybe a trusted and maybe an untrusted. That's kind of the default package in Azure. But technically, it could have only one. We will forward the traffic. If you have a UDR that points the traffic there and another UDR that points the traffic there, and you do routing on a stick or firewalling in and out the same interface, that works. And that scales a lot. Because if you do something like that, and you've got this management interface here, it doesn't matter too much, but if you have one interface of your firewall in each subnet, that's nice. Until you have more than 8 subnets. Because it's the biggest Palo Alto appliance you can put has 8 subnets, because I don't think that Azure has any VM that has more than 8 NICs. And quite frankly, it doesn't matter. So this is typically what we suggest our customer do. Something like that, where you have your appliance there, maybe a management interface, you need to have one, right? And a trusted and untrusted interface if you need these level of trust. And then have user-defined routes in the virtual networks that simply send the traffic or force the traffic to that appliance. So this, I mean, you can set it from a gazillion subnets into this as much as we support, which I don't know how much it is. I believe it might be 100 or 1,000, I'm not sure. But this appliance doesn't have to have that many NICs. As long as your policies are well configured, that's going to work. Now, high availability is another interesting thing. The built-in components of Azure, so VNet is highly available. You don't have to worry about creating a backup VNet. The VNet is there. It's not going to disappear. Application gateways, VPN gateways, ExpressRoute gateways, everything runs in double if it has to, or if not, it's part of the infrastructure. But virtual appliances, they're VMs. A VM can go down, can be upgraded. You can have a requirement to upgrade yours. And what do you do with high availability? Where there's 2 approaches. There's the active standby, which is not something that Palo Alto natively does, but focuses rather on the active scenario, which I think scales much more, and it's a much better idea in my opinion. But if you did have an active passive, you would have a user-defined route that points to NVA1, Network Virtual Appliance 1. And if it failed, some process would detect that failure and change the user-defined route to point to the new device. If the device doesn't do it by itself and you don't have a monitoring thing, you need to have somebody pretty quick on the keyboard, because you're going to lose a lot of traffic. So depending on what this is used for, it's probably not a good idea. So the other alternative is rather to do this in an active way, where you could have much more than 2, by the way. You could have 2, but you could have 10 if you want, if you need to, if you've got that kind of bandwidth requirement. And this would work with, you would have like 2 different virtual appliances, and you would point your user-defined routes to a virtual IP. So it's load balancing. Load balanced by flow. So you would need to source net those flows to make sure they return through the same firewall. It's something you might want to keep in mind, because if you don't, it's likely that your sessions are going to break. And the flows are balanced from one firewall to the other depending on the load balancing algorithm you chose. And return traffic goes to the right box. So that works pretty well. The only drawback is that you lose in my opinion, while you lose the IP of the caller, of the client. Some, security guys sometimes want to keep that identity, and you could cross-reference it using the firewall logs, arguably, but it's still not, you lose it when you had it originally. It's kind of the only drawback that I can think of. And another one, which you could, it's more management, and it's harder because you have to configure a rule on the load balancer to allow that port to go through. So it does not do any port. We're working on improving that story, but for now you have up to 150 ports, and if you do need more than that, call us. Maybe if the scenario, there's maybe things we can do to improve that. But that's kind of the story of our virtual appliances in general. And you can implement very similar policies that you would implement on premise because you configure routing in a different way. You don't do OSPF or EGRP or whatever you guys do, but you could still have pretty interesting scenarios. And in terms of scenarios, one I talked about is sharing the express route or the VPN. So you could have one topology like this, but you can also imagine that you have this topology that's in one region. I'm from Canada, so I've got my Canadian regions there, but there could be any Azure regions. And on the right, you could have the same topology replicated in another, and an express route circuit. I put Montreal, that's where I live, but one could be in Chicago, and the other one could be elsewhere. And you could imagine having two express route circuits and cross-connected to both of those virtual networks. And you could have your workloads that are facing the internet, for example, and using Traffic Manager on the web, so that even if one region comes down, that application still works. And you could have local access, people accessing it from the East Coast could access this workload, and people from the West Coast could access the other workload. And you from on-prem have highly available connections to Azure. And that could scale. You could have up to 100 guys here. I'm not going to draw that, just makes it a little crowded. So that's it. Hopefully that's a bit useful. And any questions?
So just to make sure I understand properly, within the V network, if I have a NIC running in promiscuous mode, what traffic will I see? Will I see all subnets and VLANs traffic within the VNet?
No. If it's running in promiscuous mode and you don't do UDRs or anything of the like,
yeah,
you'd see nothing. You would see the traffic that's destined to your virtual NIC.
Okay. Do you guys have an internal red team to test escaping the overlay network?
We do have a red and a blue team that do a lot of nasty things, or try to, and one working against the other. I can't answer specifically to that because I don't know.
Okay.
But I know that there's like the what do they call it? Cybercrime Prevention Center is pretty beefy there, and it accumulates a lot of data in the security graph. We populate this and we cross-reference the logs of things we see to try to find patterns of what could be going on. But it's the customer's responsibility to protect their assets, like within the virtual network. Like if you expose a web service, if there's a massive DDoS against your web service, we will probably detect it and shun it.
So if the customer authorizes me to pen test their environment, and their environment partially exists in Azure, as long as I'm not breaking like the admin interface that's an Azure.
Well, I believe in the Azure agreement of your customer, they would know that they would need to tell us if you're doing this.
Got it.
Yeah, within the agreement, it states explicitly that you have to notify Microsoft if you're going to pen test.
Perfect.
And if you would do it at scale, we would guess.
Yeah.
I mean, if you send a million bots attacking, but if you're just trying to do some SQL, I don't know that we would really see these things, but it's in the agreement that you have to divulge it when you're doing it.
That makes sense.
And all the endpoints are subject to us monitoring them, making sure they're not under attack. Look into the traffic. I mean, there's probably terabits per second of traffic going all over the place, so we don't have the resources for that. But we look for weird patterns. Any question?
All right, do you guys want to take a quick break before the next presentation? Get some drinks or food or whatever. All right, we'll just take like a 10-minute, 15-minute break.
Will we do that?
I responded.
Oh,
yeah.
that was when I spoke once and I need to stop playing my phone because it's like,
I'm like, why are you? I didn't ask the question. I don't know. I went off.
what's that?
You're sick of
Oh, Karen is here.
Is she?
Yeah.
We're gonna wait until for sure. We know somebody. I don't know. When he talked about training called digital communities,
Am I noticing
if you have a Microsoft rep and
ESM will
talk with them, you can visit it. You can visit it. It's true. It's amazing. It's like what you would think of for a knock should be. I mean, the big monitors everywhere. Been on different
Some market verticals that get paid
yeah.
some really nice
Yeah, I was just wondering.
There's a lot of things going on. We watch somebody looking for I mean, at the network layer, but at the application layer as well. So I'm getting away from two logins and some Azure property and that's pushing back to our
major BGP.
I've been excited a little bit. So these are kind of signals that populate the
There's a lot of
One
thing I can say is troubleshooting. You know, I've configured routing on a lot of different platforms, but like configuring BGP, I've never done it before, but it was insanely simple. And it made sense. Like every one of the things I've always complained about is like certain platforms are like everything's in a different location, and there's no logical flow. It's like one